push that rock here with some math. Let's look at the function f of x equals 2 to the x. So you put in the input as an exponent on 2. And the output is the power of 2. So if I put in 0, I get 2 to the 0, which is 1. If I put in 1, I get 2 to the 1, which is 2. If I put in 2, I get 2 to the 2, which is 4. If I put in 3, I get 2 to the 3, which is 2 times 2 times 2, or 4 times 2, which is 8. I didn't do any negatives, but maybe I should have done a negative and maybe even a fraction. 2 to the 1/2, well, that's a number that we can't really write in decimal form. We can approximate it in decimal form as about 1.4 something, but we write it as square root of 2. And 2 to the negative 1 would be 2 to the negative 1. That just means flip your base, you get 1/2. Okay, so this last little bit where I said 2 to the negative 1, that kind of helps us with this. What if I took 2 to the x and raised it to the negative 1? Well, we have property of exponents that says you can multiply the exponents. So x times negative 1 would be negative x. But what does that mean? It means I have 2 to the negative 0, which is just 2 to the 0, and I get 1. Okay? If I go 2 to the, put in 1, it's a negative whatever the x is, so negative 1. Well, that means 1/2. The negative means flip the base to 1/2. So what if I put in a 2? Well, I had 2 to the negative 2, which is 1/2, but it's squared because it's to the 2 power this time, not to the 1 power. So the last time I could have had to the 1, I get 1/2. So here I get 1/4. And then 2 to the negative 3, because I put in a 3, but there's a negative in front of it. And so I get 1/2 to the 3rd, which is 1/8. And if I put in negative 1, well, I'd get 2 to the negative of negative 1. Well, that just gives me 2 to the 1, which is 2. So what's happening here? And what about if I did 1/2? Okay, that would be 2 to the negative 1/2. That means flip the base, you get 1/2. And to the, yes, it's a negative, so I make it 1/2, but it's still to the 1/2 power. And so I get the square root of 1/2. Okay? Or you could write that as 1 over the square root of 2, because the square root of 1 is 1, and the square root of 2. So what's happening? Well, I'm getting the reciprocal. The reciprocal of 1 is 1, the reciprocal of 2 is 1/2, the reciprocal of 4 is 1/4, the reciprocal of 8 is 1/8, the reciprocal of 1/2 is 2, and the reciprocal of the square root of 2 is 1 over the square root of 2. So we're getting the reciprocals here. So this negative 1 applied to an algebraic expression like this means reciprocate. That's what it means. It means get the multiplicative inverse, which is a synonym for reciprocal. But it is not the inverse of the function. These are not the inverse, because the inverse of a function swatches x and y's. We have 0, 1, 0, 1. The 1 and the 0 did not change places. Okay? We have 1, 2. Here we have 1 and 1/2. 1, and then the output is 1/2. Okay, well, over here, we had 1 for the input. 2 is it. The 2 and the 1 did not switch places. All that happened was the output became reciprocated. The numerator went to the denominator, and the denominator went to the numerator. That's called reciprocation. So we do not have a functional inverse here. The function inverse of this is the log base 2. That's the definition of log. Remember, we define logs to be b to the x equals p if and only if, this assumes b is positive, not 1, if and only if log base b of p is equal to x. Okay, so that creates the inverse of function. So now when I put in 1, I put 1 here. Well, log base 2 of 1 is 0 because 2 to the 0 is 1. What if I put in 2? So I get log base 2 of 2. Well, that's 1 because 2 to the 1 is 2. That should have written the other one. What if I put in 4? Well, log base 2 of 4 is equal to 2 because 2 to the 2 is 4. What if I put in 8? Log base 2 of 8 is equal to 3 because 2 to the 3 is 8. So what's happening to the outputs and inputs? 1, 2 became 2, 1. 2, 4 became 4, 2. 3, 8 became 8, 3. So they're switching. So this is the inverse. So the inverse of f is log base 2 of x. So it's really tricky. You're used to this -1 notation meaning reciprocal. You should be. I mean, you've had that for years in school. You should be used to that. So if you're used to that meaning reciprocal, good. You paid attention to your teachers in class, and you should be proud of yourself that you understand that concept. But when you see it with this function notation, Euler function notation, you have to unschool yourself and realize it does not mean reciprocal. Not here, it doesn't. Here it means, it indicates the inverse function of f of x, not the reciprocal, not the reciprocal. So you have to get the inverse function. That's the function that interchanges the x and y's. And in this particular case, if f of x is 2 to the x, its inverse is log base 2 of x. Math made simple. It's Simpson Math.